In this class, we're going to be looking at a very interesting topic, and that topic is flay. How to cut flay. How to cut flays. Now, when we talk about flay, what we mean is simply those designs that tend to, expand or widen from the waist or from the area where it is attached. For example, we know how a flay look like, or a peplum. Most times it's narrower at the beginning, then when you move downwards it tends to widen, tends to expand. That is simply what a flay is. Now, I remember when I was starting this fashion journey, at the very first place I learned how to sew, whenever we cut our flay, I discovered that it's always excess. Yes, so we use the actual waist circumference, the circumference of wherever you want to attach the flay. You will use it and do your calculations. But when you finish your calculations and finish your cutting, you discover that that flay is excess. And most times we end up making pleats in the flay. And whereby the client doesn't want a pleat, would end up cutting. And by the time we've cut, we discover that it is no longer full. I remember a dress I made that time. It was I cut 360 flay, but when I wore it, a friend of mine, she admired the dress, but she was like, this flay doesn't look full. Is it 360? I said, yes now. I said, no, it's not full. It's not 360 flay. I was insisting that it's 360 flay because I folded it the normal way, folded it into 4, divided by 4. I was even telling her and all of that. So, but with time, I discovered the errors we were making then. Before we delve fully into the topic, I would like to mention that we have different types of flay. We have the circle flay, which is the commonest flay, and in fact, that is what comes to our mind whenever we mention flay, the circle flay. We have the A-line flay, we have the flounce, and so on and so forth. They are all flays. The one we are looking at in this class is the circle flay. Now, this circle flay, just like the name is from the circle. What we have here now on this paper is a circle. This is a circle. This is a full circle. Now, the circle has the outer edge, that's this round edge that we can see, is what we call the distance around the circle. The distance around the circle, that is the circumference. Now, from one end, from this point to this point, is the diameter. That is half of the circle. While from this point to this point is the radius. That is half the diameter. Now, the circumference of the circle is given by a formula, C equal to 2 pi. Now, when we say circumference, what do we mean? We mean any area of the bodies where you want to attach this flay. Any part where you want to attach this flay, you simply do what? You simply measure around that area. Now, I'll be using this miniature body form for this class. Now, if we want to attach this flay around the waist of this miniature, I will simply measure around the waist of this miniature, this body form, and I have 13.5. I have 13.5 as the waist circumference of this body form. What if I want to attach it on the knee? If I want to attach it on the knee of this body form, let me assume this is a knee, it is 18. What if I want to attach it around the armhole? We are simply also going to measure around the armhole. What if you want to attach it around the neck? You're going to measure around the neck. So any area where you want to attach this flay is what we consider as the circumference. That is area around this circle. It is this place that your waist is going to fit in, or your armhole or your knee is going to fit in for that flay to be attached. Now, having said that, the circle is divided into 4 quadrants, as we can see. Each of the quadrants is 90 degrees. Each of the quadrants is 90 degrees. Now, remember that the whole circle is 360 degrees. The whole circle is 360 degrees. When we divide into 2, we have 180 degrees. when we divide into 3, we have 270 degree, and when we just take the one portion of it, we have 360. So we have 90. So one portion, that's 1/4, is 90. 1/2 is 180. 1/3 is 270. Then the whole portion is 360. So 1/4 is 90. 2/4, 1/2, that is 1/2/4. 2/4, which we still cancel out to give you 1/2, which is half, is 180. Then 270 is 1, 2, 3. 90 plus 90, 180 plus 90, 270. That is 3/4. That's 270 degree. Then 1, 2, 3, 4. 4/4 is what? Is 1, which is 360. 90 plus 90, 180, 270, 360. So I hope you understand the concept. I just want us to know how we derive this formula so that it will help us understand this better. Now, the formula for this circumference of a circle is given as C equal to 2 pi r. Whenever we are cutting our flay, we are interested in the radius. That is what we are interested in when we are cutting our flay, which is this r. So our circumference is what we are using, which is this 13.5. This 2 is constant, pi is constant, it's given by 3.142 or 22.7, which when you divide will give you this value. So we have that 2 pi r. So for us, we know this now, which is 13.5. We have measured around our waist, which is 13.5. We know this value. We know this 2. And we know that pi is 3.142. So the unknown is what? R. Yes. For those of us that refuse to learn maths when we were in school, you can see that there's that maths you are running away from. You have come here to meet it. So it's not difficult anyways. It's very, very simple. And you don't necessarily need this. I'm just trying to, show us so that we appreciate what we are doing the more. So I'm still going to give us the final formula. Yes, I know some people, they are not even interested in this one. So I'm still going to give you the final formula that you need whenever you want to cut 360 flay, 180, 270, 90 degree flay. You don't need to start doing all these things we are doing here. You just use the formula straight away and get your value and continue with what you are doing. But we just want to, remind ourselves of our mathematics while in school. So, because this is unknown, we are going to make it the subject of the formula. And when we make something subject of the formula, in mathematics, we are told that that thing is going to be left alone. That whatever is attaching to that is going to leave it to the other side. And when it leaves it to the other side, it's going to come as a denominator. So we have that this r equal to C over 2 pi. So we are taking this 2 pi to come under this C, which is this C over 2 pi equal to R. So we now have that R equal to, as in this case, we have 13.5 over 2 times 3.142 is equal to 6.28. So this is how we came about this 6.28 that we are using to divide a full circle, for a full circle flay. So if I go ahead now to divide this further, I'm going to have 13.5 divided by 6.28, and I'm going to have 2.14. So this is our radius. This is what we are going to be marking out when we fold our fabric. Having said this, we are going to move to the next one. So this is how we can cut our 360 degree flay. So the next one we want to look at is our 270. 360 is the 4 of them. So I want to look at how we can cut 3, that's 270. Instead of cutting the 4 to the same time, we want to cut 3 portions out of this 4. So we already know from this calculation that our R is equal to C over 2 pi for a full circle. But we don't want a full circle, we want to 3/4, that's 270 degree flay. So we are going to divide this by 3/4. So when we do this, we are going to have, remember in mathematics, whenever we have division, it means we can do what? Cross multiply. So it means that R equal to 4 times C, which is 4C, all over 3 in bracket 2 pi. That's this 3 is multiplying 2 pi. That's this 3 is multiplying 2 pi. So we have that R equal to, what is our C? 4 times 3.15 over 2 pi is 6.28. Remember, 6.28 times 3. So 6.28 times 3 is equal to 18.84. Let me just quickly. So we have that C over 2 pi divided by 3 over 4. Then we have that R equal to 4C over 3 in bracket 2 pi. Now, we can go from here and say that R equals to 13.5 times 4. That's 4C over, this is 6 times 3.4, 3.14, which is 18.5. 18.5. And we say 13.5 times 4 equal to this divided by 18.5. So we have 2.9. Our radius is 2.9. Or if you want, from this point you can cancel out and you have that your C is times 3.142, which will give you that 13.5 over 3 times 3.142 is equal to 9.42. So 13.5 divided by 9.42 equal to, sorry, there's error. This cancels this. Okay, we are left with 2C, sorry. So we have 2 times this. So 2 times 13.5 divided by 9.42. So we have 2.86, which is approximately 2.9. So you can see, whichever way you choose to follow, they will give you the same answer. Then the next one I want to look at is half Flay. Half. That's just 2, 1, 2. This is 1, 2, and this is 1, 2. So this is half of this. So, which is half Flay. The same thing we did before. We already know that this radius of a full circle is C over 2 pi. Now we want to divide it into 2. We don't need the full circle. We want the radius for half circle. So that's why I'm dividing it into 2. So when we do this, remember we cross multiply. So we are going to have that our R equal to 2C over 2 pi. So these two cancels this, and we have that R equal to C over pi, which is R equal to 13.5 over 3.142. 13.5 divided by 3.142 equal to 4.3 approximately. 4.3 approximately. Then the last we are going to look at is 1/4. 1, 2, 3, 4. It's taking just one portion. 1/4. The same thing we have been doing. R equal to C over 2 pi divided by 1 over 4. So we have that R is equal to 4 times C, that's 4C over 2 pi. You go ahead and cancel. You have that R equal to C over pi. Okay, so when you cancel out, you have 1 here, you have 2 here, so you have 2C over pi. So you have that R equal to 2 times 13.5 over 3.142. So when we do this, we have 2 times 13.5 divided by 3.142, and we have 8.5. R equal to 8.5. So What it means is that if we want to cut a 360-degree flay, this is our radius. For this waist of 13.5, if we want to cut a 360-degree flay, our radius is 2.14. If we want to cut a 270-degree flay, our radius is 2.9. If we want to cut a 180-degree flay, our radius is 4.3. And if we want to cut a 90-degree flay, our radius is 8.5. 360-degree flay is known as full circle flay. 270-degree flay is known as 3/4 circle flay. 180-degree flay is known as half circle flay. And 90-degree flay is known as quarter circle flay. Now, having said this, we are going to go into the cutting. If you look at the values we have for 360 2.1, for 270 we had 2.9, for 180 we had 3.14, and for 90 we have 8.5. The values are increasing, they are in increasing order. So the lower the flay, the more the radius. This is also because our folds are reducing also. For 360-degree flay, we are going to be seeing it that we are going to fold our fabric into 4. For 270-degree flay, we are folding into 3. That's why we have 3/4. 3/4. We are folding our fabric into 3. For 180-degree flay, we are folding into 2. That is why we have 2/4. Remember, it's 2/4. When you cancel out, you have 1/2, which is this 1/2, half. And then for our quarter flay, 90-degree flay, we are doing 1/4. We are now folding. We are just opening it up like that. Now, having said that, we are going to cut some. We are going to cut these things, these values we have now. We're going to cut them out. Let's see how it's going to fit